Okay, so ayun. So good afternoon again, Josh, no, and welcome to another session of analytical chemistry. So for the past few sessions, we're actually having our discussions for titration curves or polyfunctional acids wherein we have this model problem. So model problem lang ito, wherein you have your zero point 0.1 molar oxalic acid titrated against 0.1 molar sodium hydroxide. No? So of course, you have a fixed volume for the analyte, which is your oxalic acid. Ayan. So, wait. Let me change this into pen. Ayan. 0.1 molar oxalic acid. The volume is 25 ml. Then, incrementally, you will add 0.1 molar NaOH. With a given knowledge that you have, di ba ang oxalic acid, ano yung formula ni oxalic acid ulit, Josh?
H2C2O4.
Okay, so how many endpoints you will have?
Dalawa po.
Okay, 2 endpoints yan. So, of course, it's already, this one is 25 and this one is 0.1 molar. And then, tinitrate mo siya against a 0.1 molar. So, matic yun na 1:1 yan, right? So, ang una mong endpoint will be 25 ml and then the second endpoint will be 50 ml. Okay?
Okay lang po.
So,
Real quick lang po.
yes.
Ikukun lang po yung calculator.
Okay, yeah. It's very important that you need to have your calculator for the next problem kasi puro calculations ito. So while you are finding your calculator, let me review quickly. So we have different stages for polyfunctional acids. If you will recall, ito yun, no? Ayan siya. Ito yung titration curve mo. So this is the first stage or the initial stage wherein you only have your weak acid. And then yung second stage mo naman will be buffer solution, no? Wherein your components of your buffer will be your weak acid and its first conjugate base, kumbaga yung HA-, no? So monoprotic pa rin siya. So diprotic acid and then the monoprotic conjugate base, no? Na ang components ng buffer mo. And then before that, before the endpoint, so the next one will be your endpoint, no? First endpoint, where in your first endpoint, you don't have any weak acids anymore. You don't have any weak acid concentration. Instead, you now have your full conjugate base, yung HA- niya, no? So, salt lang, naka-salt form ito. So, you have a certain method to calculate the pH here. And then after that, you'll have another buffer. So, wherein you'll have, this time, ang components na ng buffer mo will be HA- and then the yung fully deprotonated conjugate base, which is A2-. And then you'll reach the second endpoint, then finally you'll have the post endpoint or beyond second equivalence point. Okay? But in calculations, Josh, actually, may several stages ka. So, syempre, yung letter A, hiwalay na to kasi siya yung initial mo, no? So, this is your first stage. And then beyond 0, you'll now have your buffer region. So that's B hanggang E. Okay? So this is your second region. And they will have similar calculation methods. Pero pagkarating ng 24.9, this is just before the first equivalence point. You'll have another calculation method there. And I already taught you that. Later, i-apply natin, no? So, third calculation method iyan. And then, of course, yung 25 ml, your first equivalence point, that will be your fourth calculation method. So, up to this point, no, up to the up to the first equivalence point, we now have 4 calculation methods for polyfunctional acids. Yung initial, yung first buffer, yung just right before the first equivalence point, and then the first equivalence point. Yung fifth natin will be just right after the first equivalence point. If you will recall kasi, si number 3 and si number 5, yung third and fifth calculation methods natin, they involve the use of mass balance and charge balance equations, no? That's the concept for F and H. Because we cannot easily assume na, ay, buffer din naman yan, sir. Why can't we use the Henderson-Hasselbalch equation or the usual equilibrium method? You can't assume that because the concentrations of your let's say one of the components of your buffer will be really, really small. No, so it can you'll have erroneous results, kumbaga, no, if you will use that. And then, yung I to K, this is another stage for calculation. So this is our sixth method. So, and then, si seventh naman will be your just right before the second equivalence point. And then you'll have the second equivalence point, and then the ninth will be uh, just right after the second equivalence point, and then you'll have your 10, which is just beyond the second equivalence point. So imaginein mo, Josh, eto ngayon yung mga methods natin, no, of calculation. So when you say methods of calculation, these are basically not stages of titration per se. Kasi kung stages of titration, Josh, ito yon yung binigay ko sa'yo. Yan, yung kanina, no? So you have your initial, actually, ilan lang to? Parang 1, 2, 3, 4, 5, 5 lang, no? So initial stage wherein you only have your weak acid. And then the second stage will be buffer solution, H2 and HA minus as components. Letter C will be the first equivalence point wherein you'll have the sodium HA. So, wala ka ng H2A dyan, naubos mo na siya, na-neutralize na siya into HA minus. And then, the 1, 2, 3, ano natin, no? The fourth region will be buffer solution again. So, this time, the components of your buffer will be HA minus and its conjugate base A2 minus. And then, the fifth one will be second equivalence point. So, ayan. So, sa second equivalence point, you'll only have the solution of sodium and A2A. You don't have HA minus appreciably dito, no? Naubos mo na siya. Kasi nga, na-neutralize mo na siya. And then, beyond. Wherein yung sa beyond, you'll have excess of the titrant already. So, ilang stages yan? 6, no? So, 1, 2, 3, 4, 5, and then 6. So, 6, no? 6 stages yan na for polyfunctional acids. However, sabi ko nga, pag magsasolve ka, hindi lang yan 6. 10 ang na-produce natin dyan. 10 methods for the different titration points. Okay? So, this time, Josh, Josh, nandiyan ka pa ba?
Abo.
Ayan. This time, Josh, you will now construct a titration curve for the titration of 25 ml pa rin of 0.1 molar malic acid. So your malic acid looks like this. This is the formula, HOOCCH double bond CHCOOH with 0.1 molar NaOH. So, kung gagawin natin yung malic acid, 1, 2, 3, 4. Tama ba? 4 na carbon chains yan. 4 carbon chain yan, Josh. Tama, no? 4 carbon chain. Tapos, i-double bond mo dito. Then, this is another carbon. Tapos, ganyan siya. Double bond O. And then, another double bond O. Yan. And then, you'll have your OH here. Yan. Ganyan ngayon yung malic acid. So, of course, I really want you to see na, tingnan mo ha, analytical yung problem. Pero, you can also have organic samples in analytical problems. That's the reason why it's very important as well that you know the organic rules or organic structures or even yung mga organic properties so that you can easily predict what will happen during an analytical method. So, ito, analytical method to kasi titration ang ginagawa natin to determine the concentration of malic acid. So, actually, hindi naman natin dine-determine. We're determining the pH every time we will add a certain volume of your titrant, which is 0.1 molar NaOH. So, with that, your Kas are given. Ka1 for malic acid is 1.3 times 10 to the negative 2. Ka2 is 5.9 times 10 to the negative 7. So, with that, Josh, please calculate letter A. Yan. So, sa calculate for letter A, ano na lang ito, ha? Ito ay 0 ml. So, at 0 ml muna. So, ikaw ay mag-share screen, Josh. You can take a screenshot of this, Josh, so that you'll have a copy of this problem. However, meron ka ng copy nito sa ating G drive din. Okay? Na-screenshot mo na, Josh? Okay na?
Wala mo.
Okay. So, kahit saan naman ka, F hanggang F or G tayo today. No? So, just beyond the equivalence point. Para yung H to N naman yung next meeting natin.
Actually, nakagawa na po ako ng content.
Oh, okay, very good. Yay! Ayan, so papakita mo lang sa akin. Okay, I'll stop sharing and you can now share your
I think it
board.
should today po.
Sige.
Wala mo.
You may now share your board and show your solution.
Ano na po ako? Ito. Ito po. Yan.
Yan. And then, okay. Ayan, may mga nasimulan ka na. Of course, I need yung solution. Kasi kailangan ko makita at kailangan mong ma-develop talaga yung nagsasolve ka. I really want to see your solution there. Sige, mag-screen share ka ulit ng whiteboard mo, then show me how did you get 1.521? Yun yung una kong tanong. Tapos yung susunod ay 1.5 1.74, 2.098, tapos paano mo nakuha yung the rest?
Wala mo. Open ko lang po yung Jamboard. Para ano. Ay, ubos na yata po pala yung Jamboard. Wala mo.
Sa ano na lang dito na, sa screen siya, sa share screen nitong um, Zoom. Pwede naman dito. In infinite pages naman yata ito or hindi, kung hindi man infinite pages, definitely for each session we will not consume every pages, no?
Opo.
Okay. Saan mo sinusolve, Josh? Sa Jamboard ba or sa ano?
Open ko lang po yung whiteboard.
Okay, sige. So, yan. Then, ayan. Meron ka namang access, right?
Opo.
Okay, good.
Hmm. Sa 0.
You can start anywhere.
Opo. Dito sa dulo. Yun.
Hindi ko makita yung ano, no. Kung nasaan ka, ayun. Okay.
Yun na po.
Yeah. Eto. You're here. Okay. You may now show your solution for letter A and B. Kahit letter A muna. Your letter A is, anong stage ito, Josh?
Ito po.
Letter A. Ay,
Original.
nandito ka pala. Ay, what's happening? No. Yan.
Ano po yung ano ng maleic acid? Meron pong shortcut.
H2M, pwede mo, mag-set ka na lang. Yun yung naisip ko parang H2M. So, alam mo na yun na maliit yung mabubuo. Yan. Okay. So, for the first one, or for the first point, your volume is 0 ml. So, the volume of your titanate is 0 ml. So, no sodium hydroxide added yet. So, therefore, kanino magde-depend ang pH, Josh? Pag ganyan, how can you get your pH? Should be derived from the
From the ano po?
from the malic acid itself.
Dito po siya.
Okay? A, this is B. Okay. Hmm. You're done na ba, Josh?
Tapos,
Ha?
ano po?
You're done na? Sige, wait, let me check lang yung item. Yeah, hanggang C. Pwede na yan. Kasi ang letter D, iba na yung approach dyan eh. Let's check first your letter A. So, mag-zoom in lang ako. Tapos, ikaw ang naka-share screen, right?
Ano po?
Pwede ba dito, wala ba dito yung parang kamay, tapos para nadadrag ko na lang? Or ano siya, parang ganyan-ganyan. Kailangan kong i-move yung cursor. Anyway, so, ayan, ako yung red. Okay? So, for letter A, you have your volume of your titrant is equal to 0. Okay? So, it means, Josh, ano lang yung laman nung nung system. So, kailangan habang sinosolve natin to, you need also to understand what's happening in the species. So, anong laman ng system mo? Kung ang volume ng titrant ay 0, so it means you only have what?
Yun na po.
Yes, Josh? You only have what?
Yun na po.
Again?
Ano po?
You, you have your what? If your volume of your titrant is 0, so your system contains what? Sa letter A, 0 ml titrant eh. So it means what? You only have your
Yung ano po?
for letter A
For
muna.
that,
So I want you to understand what's happening inside your system eh. For letter A, you have 0 ml added titrant. So therefore, what is the component of your system? Anong laman ng system mo? Yes?
yun lang po. Malic acid lang po.
Okay, so we only have malic acid. So kung malic acid lang ang laman niyan, of course we know that malic acid is a diprotic acid. Why don't you have the second dissociation? Kasi
Hmm.
Ka1 lang yan eh, right? For letter A. Bakit Ka1 lang? Can't we have the contribution of the hydronium ion concentration coming from your Hm minus?
Super
Kasi di
late.
ba yung Hm minus pwede rin naman ma-dissociate yan, right?
Super late yata po.
Ha?
Baka masyadong negligible.
Okay, so usually, we will only consider the first dissociation constant, no, which is 1.3 times 10 to the negative 2. And if we can see what's the degree of difference between your ano, Ka1 and Ka2? Kung 10 to the negative 2 yung isa, ano yung Ka2 mo ulit? Your Ka2 is 5.9 times 10 to the negative 7. So it means you have a 10 to the fifth degree of difference no between the two. So it's quite big. So masyadong malaki yung gap ng Ka1 and Ka2. So therefore, if Ka1 is the main parang kumbaga ang nangyayari dito sa initial, si Ka1 yung talagang dominating dissociation no, na reaction. So you'll only have H2M plus H2O forming HM minus plus H3O plus. So we can say here that the dissociation of HM minus is negligible, forming H3O plus and M2 minus, no? So kasi yung H3O plus na mabubuo mo, Josh, from your dissociation of your HM minus can also contribute dun sa pH. Yun nga lang, dahil ang Ka2 ay napakaliit, no? 10 to the negative 7 na siya. So we can also expect that the H3O plus coming from the dissociation of your HM minus will be really, really, really small. So if that is the case, that will be negligible. And then the pH will not change even if you add the H3O plus already coming from your HM minus. Okay, so that's the reason why we'll only consider Ka1. So ngayon, ginawa mo ay yung equilibrium method. That's correct. So 0.1 minus x, then you'll have your xx as your HM minus and H2O plus. Then you create the equilibrium constant expression. So Ka1 is equal to x squared over 0.1 minus x. And then eventually you'll have the pH, no? So ano pala ang X dito, Josh? Hindi mo nakukuha lagi yung ano, H plus H3O plus. For letter A, what is the H3O plus? Kasi diretso pH ka eh. So, may mga problems, Josh, na they're only asking for the H3O plus concentration. Careful ka doon. Kasi kapag binigay mo ang pH, partial points lang yon. Kasi ang hinahanap talaga yung H3O plus. O kaya minsan, pH yung hinahanap, H3O plus lang yung binigay mo. So careful ka ulit doon. Partial points lang din ulit yon. So for this one, kumpletuhin muna natin. What is your H3O plus there? So, tsaka sino yung H3O plus dyan? Yan ba yung X? Yes, Josh? Please calculate the H3O plus here.
Mhm.
For letter A muna tayo ha. Paki-calculate yung H3O plus. Yes, ano Josh yung H3O plus?
Yung
For letter A. Like what
hindi ko
I
alam.
mentioned, for the previous problem and this problem, we will be calculating everything first, no? So pati yung H3O plus then leading to pH. So that will be, how do I say this? You'll be knowledgeable even though kung H3O plus lang or pH yung pinapakuha, you'll pay attention to details, no? So ayan, H3O plus lang. Anong H3O plus mo for letter A? Leading you to your pH, which is 1.521 is your answer. Which is, by the way, this is correct. This is also the same pH that I've got. So, ang hinahanap ko na lang dito, Josh, ay ano ang H3O plus mo for this item? H3O plus. Okay? So, what's your H3O plus, Josh? Ano ang H3O plus mo, Josh?
Ano po?
For letter A.
I have no idea.
You have no idea. You already calculated the pH. Of course, you can easily calculate the H3O
Okay.
plus.
Instead of using the calculator po, I can just backtrack. Okay, nice.
Correct. Yeah, ano mo na lang siya.
0.0
Mathematical expression.
0.0301.
Okay, sige, sulat. 0.0301, tama ba? That is what I've got. 0.0301. Sige, sulat mo dyan para at least you have, once you save this whiteboard, nandiyan siya. So, etong letter A, madali ito, no? Kasi we only have one equilibrium here. Or one system lang yung kino-consider natin. It's the Ka1 or the first dissociation only. Though we have the second dissociation, yung HM minus, since the Ka values are really, you have a quite big difference, no? So, quite big yung difference sila. We can assume here that the first dissociation constant or the first dissociation reaction will be pretty much the dominating or the dominant reaction. Kaya si Ka1 na ang ginamit natin. So, for letter A, you'll have 0.031 na 0.031 molar. That will be your concentration. Okay, for letter B and C, so combine ito. So for letter B, what's this? Ang letter B kasi natin, nag-add ka na ng how many ml? Let me check. 5 ml. So, nag-add ka na ng 5 ml ng 0.1 molar NaOH. So, to get the millimoles, no? So that will be 5 times 0.5, 0.1 rather. So that will be 0.5, right? However, Josh, saan mo nakuha pala tong 2.5? Ayan, saan to nakuha? Tong 2.5, Josh? Tsaka ibigay mo yung values nila. Ano yung mga values nitong mga to?
Yung alam mo?
Eto, ayan, yung CH2M. Kasi tingnan mo ha, kapag in-input mo naman sila sa calculator, hindi mo naman minention kung sila CH2M ba ito or 0.1x added, or 25 ml plus added. So, sino tong mga to? Eto o yan, saan to galing?
Iba po ang
Mhm.
sagot. Wait lang po.
Sige.
Baka tama yun.
Lagyan mo lang ng B and C, parang ganito. Sa B, ano yung CH2M mo? You can have this way. So, ito yung B mo. Tapos ito yung C mo. I can easily understand that na i-input mo sila dun sa equation. However, sa equation mo din, I cannot see kung saan dyan yung CH2M, CmHm, etc. So ayan, kunwari sa B, sino yan yung CH2M mo? What's the value? Then sa C, ano yung value mo rin ng CH2M? Tapos, sa B, anong value ni CNAHM? And then sa C, ano rin yung value ni sodium HM? Sodium hydrogen maleate. Para at least makita ko lang yung values niya.
Wait po, parang nagkaka-calculator error po ako. Iba yung nakuha ko kaysa sa
So I want to see lang the values of the concentration of your H2M and sodium hydrogen maleate for letters B and C. So that I can really check, no, na talagang nakukuha mo siya. Wait lang, may kukunin lang ako, Josh. Pakisulat na lang, Josh, ha. Ginawa kita ng table. Isulat mo lang yung values ni concentration of your malic acid and sodium hydrogen maleate.
okay. Alam ko na po yung nangyayari po. So, hindi ko ano pala, na ano po tawag yan, namo-multiply ko pala 'to, hindi po plus.
Mhm.
Kunin ko na po.
Kaya be careful with your showing your solutions. Kasi yan ang magiging basis mo rin for your calculations.
Oo,
Mhm.
parang niyata mo, gaano.
Just need to see the values for concentrations of malic acid and sodium hydrogen maleate for letters B and C. 0.166. 0.16 talaga yan, H2M, malic acid. Sige, you try to solve. So that's automatic 0.1 times 5 over 25 plus time. So, 0.816 for letter B. Sige nga, calculate mo muna yung sa sodium hydrogen malic. Gawin mo. 0.1 times 5 divide 30, tama? Tingnan mo. 0.1 times 5 over 30 kasi 25 ml plus 5 ml eh. What will you get? I think it's not 0.1666667, something like that. Hindi siya 0.16. Should be what? Sige, try mo, Josh, yung letter B. Concentration of sodium hydrogen maliate.
Ah,
Hmm.
1.3 times negative 2, okay. KA1 mo.
So what should be the value? Same din sa H2M mo ha, sa malic acid mo.
Nalagay ko yata po 25 eh. Kaya gano'n. Nagkaano mo ito doon. Nilagay ko yata mo dito 25. Hmm. Point zero.
Okay, so mukhang double check natin.
Tama na yata ba? I think. Hopefully.
We'll see. So, for letter B, the 5 ml, sa CH2M mo should be, 0.06666. This is correct. Ayan, nakuha mo rin. CH2M. Correct. Ito, yung CNHM, paki-check yan, Josh. Di mo pa rin siya nakuha. Ano, tignan mo, check mo. Ang laki niya, no, 0.16. Imagine mo, 0.16 molar kagad yung sodium hydrogen malic. You just added 5 ml
0.1.
of ano. Ayan, 0.016667. Okay, good. So for letter C naman, we'll have, correct? So this should be 0.03 and then 0.03. What will you notice sa letter C?
Pareho mo.
Okay, same sila. And then, ayan, so we'll have, for letter B, you will use, for the calculations of pH, you will now use the Ka1, yung longer method nung equilibrium constant expression. So wherein you'll form a quadratic equation. So you'll have here x squared plus, ito yung letter B point mo, no? So 0.1x added. So i-multiply mo 0.1 times added over 25 ml plus added. So basically, sino ito? Ayan, sino to, Josh? What is this? What variable is this, Josh? Isi-simplify mo siya para at least kuha mo na to. Sino nga ito? Ayan, Josh, yung letter B mo. Yung letter B, Josh. Sige nga. What is this variable? Tsaka ito, yan. Ano tong variable na to? So this is basically your, what? Yung nasa gitnang variable, yung B variable mo. It's a sum of what? Sum of, this will be the sum of your concentration of sodium hydrogen maleate plus the Ka1. Yan. While yung letter C mo, that will be negative the concentration, the product of concentration of malic acid. So yung remaining malic acid and the Ka1. Then once you get this, you'll have an X value. So kung sino yung positive na X value doon, syempre siya yung concentration. That will be the value of your hydrogen as well, or hydronium ion. And then you'll get the pH. Josh, can you try using the Henderson-Hasselbalch equation? Pakisulat, letter B and C. Ayan. Sige nga, ulitin mo letter B, yung Henderson-Hasselbalch equation niya. Kasi may mga concentration ka na eh. So this time your HHE method. Kasi imaginein mo, di ba? Kapag mag-aano ka pa, mag kwa-quadratic, ang dami mo pang dadaanan. Pero once you get the concentrations of your malic acid and sodium maleate, you can actually use another method. Let's say the Henderson-Hasselbalch equation method. Sige nga, kasi meron ka naman ng concentration ng acid, concentration ng base. You have your Ka1. Can you get the pH there? Sige, please try letter B and C using the Henderson-Hasselbalch equation. Mhm. Sige, please try the Henderson-Hasselbalch equation so that you'll be exposed to another method as well. If that one will work. For both letters B and C. Okay, sige. Please try the Henderson-Hasselbalch equation method, Josh, for letters B and C. Okay, so what's your answer, Josh, for the Henderson-Hasselbalch equation? Letter B and letter C. Okay, we're ready. Saan na, Josh?
Hmm.
Hmm.
Ah! Sorry po, na-input ko pala po yung Ke1 nung oxalic acid, kaya mali.
Mhm.
1.30 times 10 to the negative po yung ano, Ke1. Ay, hindi ko pala
Hmm.
sinusulat.
Okay, ayan, i-try mo, what will happen?
It's like so out of range mo.
1 point Okay. How about letter C? Sige, how about letter C, Josh? And then, what can we say about the discrepancy? Sige, letter C ka naman. Six point six six seven. Yes, Josh, what can you say? How about letter C using the Henderson-Hasselbalch equation?
Yun po. So,
Letter B pa lang yan. How about letter C?
hindi po kasi
Sige,
magiging zero. So, magiging zero yun sa ano. So, ano lang, 1.88.
sige, sige. Sulat. Ayan. Kasi nga same sila eh. Okay, I have a question. Why is Henderson-Hasselbalch equation not working for the previous items B and C? Considering na buffer sila, bakit kaya? Mhm.
Mhm.
'Di
Parang
ba very different 'yan 'no? Very different sila. Actually ito yung sagot, yang 1.742 tsaka 2.098. So correct 'to or 2.1 and 1.8. Correct yang dalawang 'yan. So my question is, buffer naman sila. Why can't we use the Henderson-Hasselbalch equation? Right? And you're also dealing with the dealing with the same concentrations, right? Same naman ang concentration ng weak acid and then yung conjugate base. Bakit kaya? Tingin mo, do you have any answer, Josh? Propositions? Why can't we use the Henderson-Hasselbalch equation in problems like this? Hmm. Yes, Josh. Bakit kaya?
I don't know po, actually. But iba, I
Bakit
actually
magkaiba sila, 'di ba? So, ano naman sila, ang
malayo.
Henderson-Hasselbalch equation ay formula mo for the for buffers. Why can't we use it for problems like this? Because number one, ang Henderson-Hasselbalch equation will only work if number one, yung mga uh, concentrations ng iyong components ay closer to one another. If we can see here, there's a big difference between the two, no? So 0.06 then 0.016. So almost 3 yung difference nila. So 3 degrees yung difference. Another, it fails to integrate fully the use of your Ka, which is 1.3 times 10 to the negative 2. Unlike your equilibrium method, ito, yan, yung equilibrium method, you are integrating the Ka1 to the formula, no? So actually, meron naman sir, ayan no, nandito siya, no? However, this formula is not interacting with your concentrations. In fact, dapat, kailangan mong i-consider yung Ka1 mo dun sa mga concentrations. Kaya tandaan mo, Josh, ha, ang Henderson-Hasselbalch ay rule of thumb sa mga ganito. Para magkakaroon ka lang ng idea kung nasaan banda yung pH. Plus, but don't use it as a formal sa part na ito ha, sa part na ito. Kasi usually for letter B, dun sa after the first equivalence point or the second buffer, yung Henderson-Hasselbalch equation nag-work na siya. Okay? So, sa first, hindi. So, kasi first equivalence point pa lang siya, no? So, it means you still have another equivalence point that will follow after. No? So, eto nagwo-work siya. Kasi yung ano mo ha, after the first equivalence point, your acid will now act as a monoprotic acid. So, mas madali yun, no? Yun yung ginagawa natin for the longest time. Para siyang weak acid na lang, kumbaga. Pero dito, hindi pa, no? So, it wills to use your Ka1 so that the Ka1 can interact with the different concentrations as well. So, kaya dapat, ang ginagamit natin dito, so X ito, definitely, no? So, because these values are really far from the values that we've obtained from using the quadratic equation method, no, or the equilibrium constant uh, expression method. So please don't use, remember, pakitandaan ito, Josh, please don't use the Henderson-Hasselbalch equation for the first buffer region. Okay, so babalikan natin si Henderson-Hasselbalch equation method sa second equivalence point na lang. Check, second equivalence point sa second buffer region. Let's try and see, no, if this one will work already. So, for letter A, tama ka, no, ang pH natin ay 1.521. And then, ang pH naman for letter B, let me check kung parehas tayo ng nasol. 1.74 ang nakuha ko, correct? 1.742. Then, for letter C naman, ang nakuha ko, Josh, ay 2.10. 2.10. Ayun. So, 2.098. So, 2.10, no? So, we have the same answers basically for B and C. However, may hindi lang ako nakikita dito, Josh. Ano yung mga hydronium ion concentrations for letter B and C? Paki-calculate lang ng really quick. Sige, Josh. What are the hydrogen concentrations for B and C? Yes, Josh, for B and C. Paki-calculate lang what are the hydrogen concentrations?
Yun. Okay. So, yung ano mo nga.
Mhm.
Mhm. Ito yung pwede. Wait. Hindi ko lang po to. Pati pwede po naman pong 25. Yung 25 ml po.
Mhm.
Para ano po, tagdan. Yung sakto sa middle. Actually, why not? Sige. So, E.
So I just want to see the hydronium ion concentrations for letter B and C.
Oo. Hindi po. Hindi, similar
Mm.
lang po sila. Yun lang po. Yung halos magkaparehas po sila. Kaya lalagay ko na rin po siya. Mm, para na-drain na. Di ba po ito yung
Mhm.
siguro puwede ko i-backtrack. Hmm.
Okay, so your X is 0.0181. So let me check. Kung same tayo. Okay, 1.81. Okay, correct. And then 7.97 times 10 to the negative 3. Okay, so these are correct, no? So ngayon, ito yung mga values mo ng hydronium ion concentrations. Next, Joshua, sa letter D, E, F, that will be for tomorrow. So update kita tomorrow, Josh, kung mamimit kita. But hopefully, I'm already home by mga 2 to 3 p.m. Okay? So baka mga 3 p.m. nakauwi na ako noon. So that we can have another session for Anakin. So we'll solve letter, we're done with A, B, C, D, E, F, G, H. So at least yun, yung mga yun, no? So these are the volumes of your titrans close to your first equivalence point, which is, ang first equivalence point natin ay 25 ml. However, iba kasi ang approach natin for D and E, right? Because we will now be using the mass balance and charge balance equations here, as well as letter G, yung just right after the first equivalence point. So please review, Josh, ha? Josh, please review the method on how we can calculate the pH or the hydronium ion concentrations using those methods. Clear tayo dun, Josh? Yes,
Opo.
Josh? Okay. So, pwede mo nang isolve after ng meeting natin tong D, E, F, G para at least you can try kung tama ba yung sagot mo, no? So, i-review mo lang yung mga previous lessons natin for points or volume of your titrans before, just right before the first equivalence point and just right
Opo.
after the first equivalence point. Okay? I'll see you tomorrow, Josh, ha? Yes.
Tapos ko na siguro po.
Mm. Sige kung kaya mong tapusin, why not? Para at least mache-check mo na lang yung mga yung mga solutions mo tomorrow for this one. And then we'll have another titration curve kasi at least mako-compare natin yung malic acid versus the oxalic acid that we had last time. Okay? So, para mayroon kang collection ng ano diyan, ng mga ang goal natin magkaroon ka ng collection of titration curves. Okay? I'll see you just tomorrow, ha? Okay, so I'll update na lang. May meeting lang din ako. Thank you so much, Josh, and regards to your family, ha? Kay Kuya Jay at kay Ate Julie ulit.
Sige po, bye-bye po.
Okay, sige. Bye, Josh!
Bye po.